So greetings to CANSAT. For this year we have the University of Waikato has developed a flight computer specifically for the competition. This was designed by one of our mechanical engineering students by the name of Rowan. So for the CANSAT competition we have down here two flight boards. They're identical. So one of these can be used as a ground station and the other can be used as a flight computer for putting on your rocket. So each board has an STM32 processor, which is fully Arduino compatible. It has 1 megabyte of flash memory and 192 kilobytes of RAM. It's got 168 megahertz clock and is a 32-bit processor. Also on each chip is a GPS module for recording location, and which you can also derive velocity. There is also a barometer for measuring altitude, and also an initial measurement unit, which has got a 3-axis accelerometer on there and 3-axis gyro. Further, so it can communicate downstairs, it has a 2.4 gigahertz radio transmitter receiver. So the ground station will be set up to receive and the flight computer will be set up to transmit. These will require antennae. These boards run off a 9-volt battery, or technically any voltage between 5 to 12 volts, and can also run off the USB-C port, which will be useful for ground station for not only supplying power but also transferring data, loading programs. There are 30 digital input-output channels and 4 power channels which are suitable for driving nichrome wire or other power mechanisms such as actuators or servos. There is a micro SD card slot on there. This is good for recording data, for recording flight data and event data, and as we were saying before, a USB-C port which can be used for power and data transmission. So to prepare the flight computer, it has to be loaded with software. First of all, make sure that you have a computer, and on the computer load the Arduino IDE program. There will be a link for this on the CANSAT site under resources. So on the flight computer itself, when you're ready to program it, there is a little thing that says boot. On those 2 pins you will put a jumper lead, and this means you are now ready to program we then connect it up to the USB-C port, and the green light comes on to say that it is connected and receiving power. And then you choose and upload any program you like to your Arduino, to your flight computer. So I'm going to start up the flight computer first.
Okay, we're just waiting for GPS lock now.
It can take up to several minutes to get a full GPS lock. When trying to achieve a GPS lock, make sure that you're not inside, because inside the metal and the concrete will often stop the signal. Now the flight computer is actually in transmit mode using the 2.4 gigahertz transmitter. So data is being downloaded onto the computer now. So the first column is the data packet.
The first column is your team ID.
And on the end of the GPS coordinates. So one of the flight computers can be used as a ground station receiving data from the rocket or from the CANSAT. The other can actually be used as a flight computer on the CANSAT. The difference is that they will use different software and different antennae.